There's this ridiculous keyboard that appears on Doctor Who with a lot of weird looking keys with interesting captions on them. There's even an Apply Earth button. You can see it's on the Tardis console right here in this screen capture I stole from the internet. But the Tardis keyboard doesn't have nearly as many buttons as the real keyboard. In fact, it leaves out all of the keys that you would find on a normal keyboard. It raises the question, can the Doctor still smurd?
Smurd?
You'll be happy to know that the Doctor's safe in the smurd department. As this screenshot from a behind-the-scenes special shows, I want to know how to use this keyboard with my computer. If I can hook it up to my computer and use it as a programming keyboard, for example. I've already taken it apart and looked inside of it, see how it works. I've Googled all of the parts on the PCBs and logic board. I've identified everything. They all seem to be off-the-shelf components that are easy to find information about on the internet. I'm not exactly a computer engineer. I'm able to do Blinky on the Arduino, and that's about it. At least that's where I was when I started this project. But I did notice the Zilog Z80 CPU when I first cracked this open. That's something I recognized. This is a Z80 CPU in here powering this board. So this keyboard itself is its own sort of mini computer. It's more than just a mini computer. In fact, the Zilog Z80 microprocessor is in a lot of popular home computers of the era. For example, the Sinclair ZX Spectrum, the TRS-80 models 1 through 4. That's what the 80 stands for. The Atom, a computer of that era, looks exactly like this. If you look at their logic boards, you can see the Z80 processor on them. Those main boards look very similar to the one inside of this keyboard. So this keyboard isn't just a keyboard. This keyboard is a full-blown computer. So I have 3 challenges here. I need to figure out what the deal is with these connectors. Thing number 2 is, how is it being powered? Thing number 3, hopefully these components are still functional after 30 years. And there's a 4th problem here, what commands this device can accept. That's not clear at all, and may be impossible to figure out. To attack these challenges, I needed to understand the electronics on the logic board a lot better than I did. The first thing I thought of was to superimpose the underside of the PCB with the top of the PCB. That way, I could see the traces on both sides and see where they go. I had to take the backside and flip it horizontally so that it would be the right side around when I looked through the top of the PCB. I inverted the colors of the underside and then overlaid it on top of PCB. Top is green, bottom is pink. You can see where the traces enter via from the top and then continue along on the bottom in pink. Now I can use a drawing program to trace out where the connections are made. I don't know if this is how it's usually done, but this is the thing I thought of. I don't need to trace the whole board, just the parts that I'm interested in. Although I found that it was a therapeutic thing to do. A little bit like coloring, but I guess for geeks. It was actually a lot of fun and calming activity, and I ended up tracing out a lot more than I needed. In fact, pretty much the whole board. I didn't have to trace much to figure out what it did. It was pretty much immediately obvious where the power in and where the ground was. It turns out actually there's 2 different powers, well 3 if you count the negative. We have a 9-volt rail, minus 9 volts, and plus 5 volts. The 9 volts are connected to the audio circuit, which is more or less isolated from the rest of the board, as well as the 9-pin connector on the other side of the board. In fact, that 9-pin connector on the left-hand side isn't connected to anything on the left-hand side except for a little capacitor. Everything else is wired directly to the 50-pin connector on the right-hand side. It was also pretty easy to figure out what the pins did on the 50-pin connector on the right-hand side. It feeds the board power, and it does serial input and output through RS-422. RS-422 is a standard serial connection that was designed to be robust against electromagnetic interference. It's a pretty standard connection. This board seems to have 6 different channels. That's a lot. Some of these are connected to the 9-pin connector directly, and so I don't really know what they do without knowing what that 9-pin connector does. There are only 4 pins in the red dotted area right next to the green ground. I don't really know what they do. They're connected to a buffer, and then they go off into the innards of the board. I'll have to ask a better engineer about that one. So we've solved 2 out of my 4 problems. We know what this 50-pin connector does. We know how the board is powered. There are 2 other things. Are the chips still viable? Do they still work after 30 years? And is it possible to reverse engineer this thing enough to figure out what it does, what the commands are, how it communicates? So we have a lot more to do on that front.